For section 9.3, we are going to be solving linear systems by substitution. So our substitution method, there's 3 steps. Step number 1 is to solve for one of the equations for one of its variables. And sometimes step number 1 is done for us and sometimes it's not. So you pick one equation and one variable, so you could either solve for x or for y. Step number 2 is you're going to substitute that expression in that we get one from step 1 into the other equation and solve it for the other variable. And then step 3, we're going to substitute the value that we get from step 2, so our answer from step 2, into one of the original equations. So back to the very first problems, you pick one of those and you plug your answer back into that and you solve to find the other variable, the one that's missing. So it's kind of confusing with just words. So here is an example. We have to solve by substitution, it says here. Step number 1 is to solve one of them for a variable, but that is already done here. This is solved for y. So we know y is 3, so we're going to substitute that into the other equation for y. So this is going to be x plus 3 equals 5. And then I have to solve for x. So I'm going to subtract 3 from both sides, and x would be 2. Now, normally I would plug this back into one of the original equations for step 3, but notice it says y equals 3 and x equals 2. We are done. We have both numbers, so this one didn't need a step 1 or really a step 3. So our ordered pair, x is 2 and y is 3. So be careful that you put them in the right spots. Just because we had y first doesn't mean it goes in the first spot of our ordered pair. All right, now this one, neither one are solved for y, so I have to pick one of the equations and solve it for y. I'm just going to pick the top one since both are y's without a coefficient, so it does not matter. So I'm going to do the top one. I'm just going to rewrite it over here so I can show my work. I'm going to add 3x to both sides. So y equals 1 plus 3x. And that was step 1. Step 2 is now we have to take that. Y is equal to 1 plus 3x. And we're going to replace this y with it. So our new equation is going to be 4x plus our y is 1 plus 3x. And this says it equals 8. So we're going to combine like terms. Remember the equal sign. Combine 4x and 3x on the front. So that would be 7x. We have a plus 1. And then we have equals 8. Now we have to solve for x. So we're going to subtract 1 first. And then we're going to divide by 7. So x is 1. So I can go ahead and start my ordered pair over here. X is 1. Now we're going to do step 3. We're going to substitute that in to one of our original equations. And it does not matter which equation we pick. I'm going to pick the bottom one because I see that 3 is negative and I don't want to work with negatives if I don't have to. So we have 4x and x is 1 plus y equals 8. And then simplify or multiply here, multiplication. So 4 times 1 is 4. And then we're going to subtract 4. So y equals 8 minus 4, which is 4. So then we have our ordered pair of 1, 4, the point where the 2 lines would cross. And then this example, this one's already solved for y, so I don't need to do step 1. I'm going to replace that y with that. So I'm going to have 2x, and then my y value is x minus 4 equals 5. And then I'm going to combine like terms. I have 2x plus 1x, so that would give me 3x. I have a minus 4 equals 5 left. We're going to add 4 to both sides. Oops. Then divide by 3. So x is 3, so I can start my ordered pair. X is first. And then we're going to take that, x is 3, and substitute it back into one of the equations, one of the originals. Looks like the bottom one would be the easiest, so I would have y equals 3 minus 4. And 3 minus 4 would be negative 1. So my y is negative 1, and the point where these two lines cross would be 3, negative 1. And our last one here, we have to solve for a variable. And I'm going to pick x in the top equation because it does not have a coefficient. And that just means that's one less step I have to do to solve for x. So I'm going to rewrite that equation over here. And I have to get rid of that 3y. So I'm going to minus 3y. So x is equal to 6 minus 3y. So I'm going to take that and replace the x in the other equation. So I'm going to have 2. And then our x value is 6 minus 3y. And copy down the rest, plus 6y equals 12. And now we have to simplify. So this 2 out front means I have to distribute. So 2 times 6 is 12. And 2 times negative 3y would be negative 6y. Plus 6y equals 12. Combine like terms. Negative 6y and positive 6y make 0. So we end up with 12 equals 12. That is a true statement. So this is infinitely many solutions. If we would have ended up with, let's say, 10 equals 12, that is not a true statement. So that would have been no solution. So that's the difference between those two. When the variables cancel out, then it's either infinitely many or no solutions.